My name is Mete Atamel. I am a developer advocate at Google, based in London. But I probably spend like 3, 4, or 5 times a year in Amsterdam because there are so many tech conferences here, meetups, and customers. So it feels like a second home to me nowadays because of my job. Today, we're going to talk about gRPC. But before I start my talk, so this is my Twitter, my email, and my blog. I'm going to put the slides at my Twitter account. So if you just want to follow me on Twitter, I'll have the slides right after the talk. I also have a talk feedback. So if you like to talk or if you don't like to talk, let me know. I am always looking for feedback. I have some gRPC T-shirts. So people who fill the feedback, the first 5 of them can get T-shirts. But then for the rest, I also have stickers for people. All right, so the agenda we have today is first I'm going to talk about RPC. I'm sure most of you know what RPC is and what it stands for. But we'll just get everyone on the same page. Then we're going to talk about the gRPC basics. So what is gRPC, what its design goals are, and what it's trying to do, basically. And then after that, we're going to look at some code. So we're going to build like a really simple hello world kind of application in Java. Who are Java people here, by the way? OK. And are there any .NET people? OK, a few. So what I'm going to do is I'm going to show first some Java samples, and then .NET samples, and then I'm going to show the two working together. Because for me, one of the biggest things about gRPC is that it's like multi-language, and I'll basically show that. But it doesn't matter if you're not Java or .NET person. All of the stuff I'm talking about applies to pretty much all the languages as well, and we'll talk about that. So after that, we'll talk about the benefits of gRPC, so HTTP2, protobufs, multi-language support, connection options, things like that. And then in the end, I'm going to show you a chat application where you have a Java server, Java client, and a .NET client, and they're all working together. And in the end, we might have some time for questions, but if not, I'll be around, so you can ask me after the talk as well. All right, let's do an intro first. So regular procedure call. So let's say you have a service, very simple service that has a greeting method that takes in a string, and it returns a string, right? And then if you want to use this, you have let's say it's a client. You create the service, you call it directly. Everything is really simple because everything lives in the same machine. In JVM, so you don't have to worry about connections, you don't have to worry about anything, everything is there. So that's what we are used to. Now, in remote procedure calls, this is a definition from Wikipedia. It's a long definition, but I think there are 2 key things here in remote procedure calls. First, the service and the client, they're separated. So they're separated by network, they're separated by internet. Somehow they're not in the same machine, they're not in the same JVM, right? And the client wants to talk to the server. But the thing about RPC is that the client wants to talk as if the server is local. So the client doesn't want to deal with the connection details. The client doesn't want to deal with how the connection happens. It just wants to do the regular call to the server as if it's a normal local call. So that's what RPC is all about. Now, at this point, our simple app kind of looks like this. So the service lives in some kind of server, and then the clients can be either like mobile or desktop or something like that. And then in the middle, there's some kind of network, right? So now we need to get from here to here. So we need to answer some questions. The first question is like, how does the client call the service, right? Like we need to think about that. It's not in the same JVM anymore. It's not in the same machine anymore. So is it going to be a TCP connection? Is it going to be HTTP call? Is it going to be WebSocket? So it's something you need to think about. The second thing is, how does the server actually expose the service? So we have the greeter service, and it has one method. But what if we have more services? Or what if we have a single service, but we have multiple methods? We don't want to probably expose all of them all at once. We want to pick and choose what we want to expose. So how does that work? Now, once you decide how the client is going to make the connection and how the server is going to expose its services, you need to send basically bits and bytes over the wire. So how do you serialize those bits and bytes? Do you use XML like we used to do, or do you use JSON, or do you use a binary protocol? You need to make some choices. And then the nature of the connection. Do we want to have a socket connection, or do we want to have like a request and reply kind of thing in HTTP? Doesn't matter, maybe not. And then authentication. You probably don't want everyone to call your service, so you need to have some kind of authentication probably. So what are you going to use? Like, are you going to use token-based authentication or something else? So at this point, even though our service and the client are really simple, like we already have a lot of questions to answer just because they're separated by the network. Now, at this point, you have two choices, right? The first thing is you can actually build your own custom RPC framework and just implement what you want. There are pluses and minuses, as in software engineering, everything is all about like pluses and minuses. The plus is that you can build it exactly how you like it. So whatever you need, you can just figure it out and build it how you like it. And I actually did this myself at Adobe. We built something called Adobe Flex Data Services that I'm going to talk about shortly. But then the drawback here is that you basically have to answer all these questions and you need to implement them yourself. So it's not that trivial. And the second option nowadays is using something like gRPC, like an open source framework that you can rely on, basically. In here, the plus is obvious. You can reuse the code. And all the questions that we talked about, they're already answered. There are already implementations of them in many languages. So you can just rely on them. But the drawback in this case is that gRPC has a certain code style. For example, in Java, it relies on builders. So you have to have a builder to get to the actual object that you need. So you need to like that style, or you need to at least be able to put up with that style of coding, right? Like some people feel really strongly about the code style. Maybe it's not for them. But for me, it does a lot of things, so I kind of got used to the coding style. And I'll show you those coding styles shortly. And then just to talk about my story of building RPC frameworks, when I was at Adobe, there was Flash, right? Like you guys remember Flash. Flash was on every device you can imagine at the time. This was like 10 years ago. And the problem was that the Flash was mostly used for games. It wasn't used for applications. So Adobe created this framework called Flex, Adobe Flex, basically, to create rich internet applications, they called. So you use Flex to create these rich internet applications. They run in Flash. And we created a tool called Data Services to connect those Flash clients to Java backends. So we basically built this whole thing that had all the connection options connecting to all different kinds of clients, like Flash clients, Java clients, HTML5, Air, stuff like that. And then we had all these like services, like remoting services, like it was RPC, messaging service. And in the end, we were basically exposing Java classes to Flash clients. And it worked great. But then what happened, and we probably spent like 2-3 years to build this whole thing, because we initially started with the Flex and Flash clients, but then we eventually expanded to all different kinds of clients. So what happened after that is that at some point, you remember this guy, he wrote a letter called Thoughts on Flash, and he basically explained why Flash is not going to be on any iPhone devices ever. So he went through some technical reasons, and some of them are true, some of them were kind of exaggerated in my opinion. But in the end, he basically didn't want a third party to come between Apple and developers. And that kind of killed Flash, and Adobe switched gears from Flash to JavaScript. And that also killed our data services framework. So all the time and effort that we spent into building this RPC framework was gone with this one letter. And I remember that day. And I actually had to switch groups from one group to another group. And I switched from Flash to JavaScript. And I had to pull my hair out because of switching from ActionScript to JavaScript. And I'm still missing JavaScript after all these years. But the moral of the story is that if you build something yourself, it's great when it works. But then when something like this happens, you're basically left in the cold. So now I'm kind of wish that I started with something open source and built that instead, so we could have like used that instead. But thankfully, we have gRPC nowadays, so we can use that. And at this point, you might also ask, like, why don't we just use REST? You know, isn't REST good enough for things? Like, why do I have to worry about gRPC or RPC in general? And the answer I give to people is that, you know, if you can use REST, then just use it. Because REST is, you know, we know REST. It's been working for a while. We know the HTTP words get, post, put. We know how they are supposed to work. So if it works for you, use it. But then in more complicated scenarios, like, for example, if you think about a bank, and when you want to transfer money from one account to another account, so you want to write some kind of like a banking service, it's going to probably be more complicated with HTTP REST, right? Because you need to make multiple HTTP REST calls, and then what if one of the calls fail? You have to have some kind of logic on top of HTTP. So you basically need to build some kind of framework on top of it anyway. So gRPC gives you that framework, so you don't have to worry about these low-level calls. Instead, you build your bank service, and then you create your method called transfer, and then you have your from account to account and the amount, and then all the complexity is abstracted away from you. And I'm going to show you what I mean in the code shortly. And also, one other thing I like about gRPC is that it's strongly typed. So it means, so you create a service definition, and then from there you have client and service stubs, and all the connection is handled through these stubs. But as a user, you're dealing with bank service. You're dealing with calling a method on a bank service. So you're not dealing with calling HTTP requests, making HTTP requests. So I think that's good because it's strongly typed. It makes like development easier, and you know what you're calling and what are the parameters, things like that. And you also get a lot of efficiency with HTTP2 and proto buffs, and we will talk about those shortly. All right, so the basics of gRPC. It actually doesn't stand for Google RPC. It stands for gRPC, Remote Procedure Call, so it's like a recursive definition. It's open source, and the key thing about gRPC is that it's very efficient. It tries to be really efficient because we do a lot of RPC calls at Google. So every little bit of savings we can get gives us a huge savings somewhere. So we make sure that gRPC is as efficient as it can be. It actually came from something called Stubby. So Stubby is like an internal RPC system that we use at Google. So the people who worked on Stubby for years, they learned from it, and they created gRPC for the open source world. And then it's open source now. It's been developed by a community, and the latest version is, I think, 1.2. And it's out there on GitHub, so you can actually look at the code. You can contribute if you want to. There is a website that explains the design principles of gRPC. I'm not going to go through all of them, but I just want to point out a couple of things. The first thing is, in gRPC, we think of services and messages. So you have services, and you pass messages to those services. We don't think of objects and references. This is intentional because in distributed systems, people think of objects and references, and then they get into this problem of thinking that this is not an RPC call, but it's like a local call. And when things don't work, they don't really handle it properly. They kind of forget that it's actually a distributed system. So to avoid that, in gRPC, everything is a service, and you pass messages to that service. So that way, you always keep in your mind that you're actually calling a service. You're not calling something local. It's free and open, so that's very important, as you know from my story. And it's very performant. And I'll quantify what that means later in the talk. So how does it work? At the high level, you start with a service definition file. So you create a single file that defines your services and what happens within your services. And I really like this because when you look at your code base initially, you don't have to actually look at your code base. You can just look at your service definition file, so just one file, and get a high-level understanding of what your services are and what your methods are. So from this service definition, you generate what's called stubs. So you generate code for client and for server. So these stubs basically handle all the connectivity between the client and the server. And then the client and the server, they extend from these stubs and add their own functionality on top. Then you get efficiency in serialization with protocol buffers, and then you get efficiency with HTTP2 for the connection itself. And then you have a bunch of options for the connection. You have unary connections, client-side streaming, server-side streaming, and I'll talk about these shortly. And then you also have authentication options. And by the way, all of this stuff is really pluggable. So for example, by default, most people use protocol buffers because it's really efficient. But you can plug in whatever kind of serialization you want. Like for example, Microsoft recently, they plugged in Bond on top of gRPC. Or if you want to do just plain JSON, you can do that as well. So everything is quite pluggable. All right, so at the high level, this is how it looks like. So let's say you have a Java service, and then it has a gRPC service that you basically generate from this service definition. Then you have a couple of clients using that service, but they are talking to the service using the stubs that is already generated as well. And then your service can talk to other services. So maybe it's talking to a Python service, again, through a stub, and then maybe your Python service talks to other services. So you can use gRPC basically for client-to-server communication and also from server-to-server communication as well. And all of the connection details, all of this code is generated for you, so you don't have to actually worry about that yourself. All right, so that's enough talk. So let me just show you how this looks in code in like 4 easy steps. So the step 1 is to actually create that service definition file that I talked about. So it will look like this. First, we'll say this is a greeter service. As I mentioned, everything is a service in gRPC. And this is a method. So it's an RPC method that takes in a request and returns a response. Now, we need to define what these requests and responses are. So the request is a message. So we are passing messages between services. And it only has one string called name. So basically, the request is just a string. But this message can be as complicated as you need to be. So it doesn't have to be just one thing. It can be a full object, basically. And then response is also a message. So you take a string and you return a string. So this is your service definition file. Then from here, you will generate the code for client and server to talk. So if you are a Java person, you would use protobuf Maven plugin for Maven, or there's also a Gradle plugin for Gradle people. So you just point the Maven or Gradle to the service definition file, and from there you get the generated code. If you're a .NET person, you can get this gRPC tools NuGet package, and it does the same thing basically. It just generates code from the service definition. Then the step 3 is to create your server. So creating the server basically involves create a class that extends from the stub and add your own implementation. And I'll show this in Eclipse shortly. And the fourth, you create a client. Creating a client is a little bit more complicated because first you need to define the connection that the client is going to have to the server. So for that, you create a channel. Once you have the channel, you need to decide how you want to talk to the server. You can talk to the server in a blocking way. So when you make a call, it blocks until it gets a response from the server. Or you can also have async calls as well. So when there's something, the server calls you. So depending on what kind of flavor or connection you want, you either do a blocking call, you create a blocking stub or non-blocking stub using the channel. Then you create a request, you send the request, and you get the response either synchronously or asynchronously. And that's it. So let me show this in Java. And by the way, all this are on GitHub. So if you just go to my GitHub, they're there, and you can try it yourself. So here I am in Eclipse. And I have this greeter server. Let's just look at the proto file first. So this is my service. Just like I showed in the slides, it takes in a request, it returns a response. But in this case, the request is a little bit more complicated. So it has a name and also age, and then it has like hobbies. Repeated means list in gRPC world. It has a bag of tricks, which is a key value pair, so it's a map. And then it has something called sentiment, which is an enum. So it's a more complicated request, but this can be as simple or as complicated as you want. This sentiment is an enum, so I also define what that means. It's like happy, sleepy, or angry, so it's a person's sentiment basically. And then response is just a greeting, so just a string. So once I define this, I have here I'm using Maven. And then if you look at my Maven, there's a protobuf Maven plugin, so I just have that, and by that I will get some code generated for me. So if you look at the code under here, target generated, you'll see that there's a lot of code that's been generated, like greeter, request, response, builder, stuff like that, and the actual service itself. Let me just show you one. So this is the generated code, and as you can see, it's quite ugly, as in every generated code. I don't usually look at this because I don't have to, because everything is strongly typed, so I can just write my code and just from IntelliSense figure out what I need. But usually you don't need to touch this code at all. What you need to do is first you need to create a server, right? So creating a server is basically first you build a server. So to do that, I am using again, I mentioned that in Java world, gRPC relies on builders. So I'm getting a server builder for the port, and then I add what's called a service. So this is going to be my implementation of what the server is going to do. And then from there, I do build, and I get a server. And then all I need to do is just start the server. So this is all there is to create a server. The key is this guy, service implementation. This is a class that you implement yourself. So this extends from this base class. This is the generated stub that gRPC gives to you. Again, I'm not looking into that because I don't have to. All I need to do is, by extending this class, I can overwrite this method. And this method is basically my implementation of what's supposed to happen when I get a request. So I get a HTTP request, and then response observer is how I respond to the client. So what I'm doing here is I'm getting a greeting, I'm getting a request, And the request is strongly typed. So if I do request, you'll see that I can see the age, hobbies, and stuff like that for the person, which is nice. But I am just getting the name of the person, and then I'm generating a response. Again, I'm getting a builder. From the builder, I'm setting a greeting that I just construct here. And then from there, I get a response. And then I use the response observer on next to send the response. Actually, to send the response, and then I call onCompleted to commit the response, so make sure that the client actually receives it. So this is the server. And if we just look at the client, so in the client first, as I mentioned, you have to create a channel. So that's how the client talks to the server. I'm creating a channel for this host and the port. And then I'm saying use plain text true. This means that don't use HTTPS, just use plain HTTP. Because I don't have certificates set up here, and it's just demo. So I get the channel, and then from channel, I need to get a stub. So in this case, I want the stub to be blocking. So when I make a call to the server, I want the stub to actually block. So I, again, use this generated code, and then just say, give me a blocking stub, and pass in my channel. And then once I have the stub, basically, this is how I talk to the server. So I create a request. So this is the request from client to the, what happened? All right, cool. So this is the request, and then on the stub, I just pass my request. So stub, as you can see, the stub is strongly typed, so from here I can tell that there's a greeting method, so I pass in my request. And since this is a blocking call, I will get a response right away, or until the server responds, and I'll just print that out. So that's how it is, and let me just show you quickly that it works. So we are starting the server now. So the server is starting, and it's already started. And then if you look at the client, I messed up something. Oh, I need to regenerate the code because okay, but believe me that it works. I have to basically regenerate some code. It happens sometimes. Maven is kind of a pain sometimes. But basically, maybe I can show the .NET one. So I have the .NET versions as well, so let me just try to run those instead. So this is the server. This is the client, and then, .NET works. That's why I switched from Java to .NET a couple of years ago, you know? All right, so let me go back to my presentation now. All right, so now that we know how gRPC works at the base level, so let's look at the benefits of gRPC. So the first one is HTTP2, and we'll talk about what that means. Second one is serialization, so either protocol buffers or bond. The third one is the multi-language support. So no matter what kind of language you're using, gRPC supports that, and I think that's a great thing to have because you can have different development teams work on different languages. It doesn't really matter as long as you have a common service definition. From there, you can get stubs, and you can just call each other, and you don't even have to use the same language. And I think that's a good thing to have. And the connection options, the different connectivity options that you have in the client and the server. So now let's talk about HTTP2. So if you look at HTTP, it started around like 1991, which was a long time ago. And then we had a version, HTTP 1.10 version. And then we had HTTP 1.1, the upgrade to 1.0. And then that's basically what we've been using since 1997. And in that sense, it's very successful because like there aren't that many things in the tech world that last that long. But HTTP 1.1 actually lasted that long. But it has some major problems. One is the limited parallelism. So in HTTP, any HTTP 1.0 or 1.1, you need to create a TCP connection for every HTTP connection. So that means that the number of HTTP requests that you can have is limited by the number of TCP connections that you can create from the client to the server. And most browsers, they would limit this number of connections for you anyway. So you couldn't have that much parallelism in HTTP 1.x before. So what would happen is in HTTP 1.0, for example, you would make a request, and then it will go to server, then you will get a reply, and then you will make another request. So you have to keep waiting for replies before we can make requests. This was easy to think about, but it wasn't efficient. HTTP 1.1, they introduced pipelining. So with pipelining, the idea is that you can send requests, multiple requests, and then get responses. But the problem in this case is that you still need to get responses in order. So if this guy is late, then all the rest, they still have to wait to respond. So even though you can send multiple requests to the server, you can't really get the responses in any order. It has to be ordered. So it doesn't really help you that much. The other thing was the protocol overhead. So there were HTTP headers, there were plain text, they were sent over and over again all the time. There was no compression, there was nothing there. So that was a lot of overhead for us. So what happened is that around 2009, at Google and other people as well, they started working on something called Speedy to address some of these problems. And Speedy turned into HTTP2. So now everyone is behind HTTP2. So all the stuff that all the stuff that happened in Speedy, they kind of got rolled into HTTP2. So in HTTP2, basically it was released in 2015, and the main goal is to improve the end-user latency, the perceived latency. So we want people to basically, when they look at latency, they perceive that it's really good. And this header line blocking issue is completely gone in HTTP2. It doesn't require multiple connections, so you have a single connection, and it tries to minimize the protocol overhead. So all the overhead of HTTP1, HTTP2 tries to get rid of it. So just to let you know how it looks in HTTP2. So in HTTP1, if you want to make an HTTP post request, you would do it this way. It was like one thing. Whereas in HTTP2, there's this notion of frames. So you have a header frames and data frames, and they're separate. And that means that they can be sent separately. And so you don't have to basically send everything all at once. There's like compression, there's streams, and I'll talk more about this shortly. So there's like the notion of streams and messages and frames. Instead of this, I'll show you the actual picture, so this makes it more clear. So when you have a client and a server, you basically have a single TCP connection, and over that TCP connection, you have multiple streams. So these streams are kind of like multiple HTTP connections, but it happens over a single TCP connection. So here we have stream 1 that has the header frame, and then stream 1 have the data frame. They are sent whenever, basically. So they don't have to be sent together. And there are other streams that's happening in between. So we have another stream for data, then we have another stream for stream 3, and then the server can also respond. So the requests can go in any order, and the responses can come in any order. And the client and the server, they can keep track of this over a single or a single TCP connection, which is great because once you set up the connection, it can be reused for multiple streams. So you don't have to keep recreating connections. So this is much more efficient because it's a single connection, and the frames can be sent in any order, and you don't have to wait for anyone, basically, to reply. You can send them in any order and get them in any order. The second thing about HTTP2 is the header compression. So if you look at HTTP1, when you send a request, you would send it something like that. In HTTP2, you also send it like that, so there's not much difference. But then the difference comes in the second request. So in the second request in HTTP1, you would send the same thing, pretty much the whole thing. But when you look at it, it's pretty much everything is the same except the path. But it doesn't matter. You still send the whole thing. Whereas in HTTP2, you only send the difference because the client and the server, they keep track of the headers that has been sent. So there's a lookup table, and they kind of figure out what needs to be sent and just send that. So because of that, it's much more efficient because what you're sending is much smaller, and also it's compressed using this Huffman code thing. I don't know much about it, but basically, whatever you are sending it's much smaller and it's compressed, so it's not plain text. So what this means for you is basically this: like the images load much faster, and let's see if it actually works. So you can go to the site yourself if you want, http2demo.io. So this is an image that's being loaded by HTTP 1.1. So it's like 10 seconds. So let's run the same thing in HTTP 2. It's 1.5 seconds, so it actually works. All right, so this kind of handles the connection efficiency that you have with HTTP2. Now, what else do you have with gRPC? The other one is the serialization efficiency, so what goes over the wire. So what most people use is protocol buffers with gRPC. And at Google Cloud, we actually have a service called PubSub. It's a public subscribing messaging framework, and it has some endpoints. It used to be in JSON and HTTP, and we implemented recently a gRPC endpoint as well. And this is what we've seen. So by changing from JSON to gRPC, we got 3x increase in throughput. But more impressively, we also did the 3x increase with 1/4 of the CPU resources. So that's kind of the efficiency that you get with protocol buffers. And if you use something like a bond or something like that, it's also the same thing. So JSON is great for, for understanding. You can look at it, you can read it, and most of the tools work with it. But if you need this kind of efficiency, then you need to move on to some kind of binary protocol. And that's what we do here with protocol buffers. And if you want to read more details about this, there's a blog post here on that. And then lastly, for me, one of the most important things about gRPC is that multi-language support. So all of these languages are supported with gRPC, and all of these platforms are supported as well. And if there's a language that is not here, you can easily add it because it's open source and it's out there. All right, so now in this part, I was going to show you the greeter server and client in C#, but I'm not going to do that because I already kind of did it in the demo. Instead, I'm going to show you some other demo later. And we don't have that much time anyway. So last thing I want to talk about is the connection options. So as I mentioned, gRPC provides a lot of different connection options between the client and the server. So first, you have the unary connections. So this is the regular HTTP request and reply. So you can have that. You can have server-side streaming. So you can open a connection, and then the server just streams data constantly to the client. So that's useful for, like, say, stock applications where the client connects and you want to send stock updates, something like that. You can have client-side streaming, so the client just streams to the server all the time. Or you can have bidirectional streaming, so the client and the server, they can stream to each other at any time. So this is huge because all of this is like implemented for you. In my own case, in Flex Data Services, I actually had to implement these one by one. It takes a long time, actually, to implement all of this by yourself. So the fact that this is given to you I think it's a huge time savings. So now what I want to show you is a simple app that has a Java server and a Java client and then a .NET client. And it's a chat application, and it's going to use bidirectional streaming, and they're just going to talk to each other using gRPC. So here I have a chat server in Java. And again, you always start with the service definition file. So this is my service definition file. So what I have is a chat service that has a single method called chat, and then it takes in a chat message. So this is a message from the client, and then it returns a chat message from the server. So basically, it takes a client's message, and then it sends it out to all connected clients. One thing that you'll realize is that these are marked as streams. So by marking this as stream, you're saying that the connection from the client and the server is streaming. And then by marking this one stream, you're saying the connection from server to client is stream. So you're basically setting up a bidirectional streaming connection by just marking your service with stream. And that's how it is. So with that, we have a chat server. It's pretty much the same as before, except the service implementation is a chat service implementation. And if you look at the service implementation, it's a little bit more complicated because it's streaming example. So what we do is we have a method called chat, and we get what's called a response observer. So this is your connection to the client, basically. So once we get one of those, we add them to our list. So the server keeps track of who's connected, which client is connected on the server. And then I just basically return a stream observer. This is the guy that handles what happens when I receive a message from the client. So on next, that's when I receive a message from the client. I just print it out, and then I create a message server message. So I'm basically wrapping my client message with a server message. And then I just go through my observers, and then I just pass my message. So basically, I get a message, I wrap it into a server message, and send it out to connected clients. There's also an on error and on completed. So this is what happens when a client disconnects, and this is what happens when there's an error. You should really handle it. I'm not doing it here. So that's the server, and then if you look at the client, so the client is a JavaFX client. So we can ignore all of this like UI code. The important part is here. Here we are creating a channel again, and then we are creating a stub. But then the difference in this case is that this stub is not a blocking stub anymore. It's an async stub because we want chat to work asynchronously. We don't want to send a message and wait for a response. So once I have the stub, I basically call the chat method on the chat service. So I get this method back, and then, sorry. And then here, again, I override some methods. So this on next is what happens when I receive a message from the server. I basically just display that in my UI. And then on error and completed, I just say disconnected. And then when I actually send the message from the client, I create a chat message. I set my name, my message, and then just use that chat object that I had to pass messages to the server. So that's how it is. Let's try to run this. All right, server is running on port 8080, and then, and this is my client. And then now let's look at the C# one. So in C#, I also have a chat server, but I didn't set it. So let me just show you the actual Windows Form version of it. So in Windows Form, I do the same thing. Again, I'm creating a channel. It's the same thing. And then in C#, they don't have this notion of stubs. They call them clients. So what I'm doing is I'm getting a chat service client. So this is the actual object that I'm going to use to talk to the server. And then when the form loads, I basically just call that chat method, and I get a callback. And then I have something called response stream. So this stream basically will include my messages as they come in from the server, and then I just call move next on it. By the way, in C#, there's this async await thing where you can actually make calls as if they're blocking, but when you await them, they don't block. So you will basically get them asynchronously. So that's why I think C# is more cutting edge nowadays, because you can actually, instead of having these methods and overriding on next, on completed, you can easily just do this and just await that, and that's asynchronous. So with this, I get my server message, and then I just display that message, basically. So let's run this guy as well. And I think I have 2 minutes left. So this is C# guy, and this is Java guy. Let's see if it works. Yep, and as you can see, like whenever I'm sending a message, the other one gets it right away because it's bidirectional streaming. All right, and by the way, the code for this is also open source. I think, yeah, the code for this streaming is also open source on GitHub. If you just find my username on GitHub, you'll see the code. And that's it, really. So if you want to know more, I mean, this is just like the basics of gRPC. There's much more info on gRPC page. And then this is my Twitter, where I'm going to put my slides. And then if you have any feedback about my talk, it's here. If you fill the form, or come and get a T-shirt. And if you want to get stickers, they're here. Thanks very much. Do we have time for questions? OK, we have some time for questions. I guess I have to put this on now.
So, hello.
Hey.
So this protocol is based on HTTP2,
yep.
as you said. I wonder why it's not, why HTTP2, why not pure proprietary protocol of Google based on TCP?
Well, because HTTP2 is where we are putting all our effort, because we started with Speedy, right? That's what we are doing, and then we realized that other people have the same problems, and HTTP2 came along that solves most of those problems. So we are trying to basically standardize everything on HTTP2. So why create something new when everyone is trying to improve HTTP itself?
Okay.
Can we have more questions? Yeah?
Thank you for the talk.
Thanks.
I was questioning, how do you handle multiple versions of a single service?
Multiple versions. So in the service definition, you can, let's say you have a message, you can add additional fields, and that would be okay because the client and the server, there's like a number, right? Each one has that number, 1, 2, 3. So from there, they can figure out, like if the client is old, it won't read the new ones. So it won't cause any problems. But and if you add a new method as well, that will be fine. The client won't call that method, and it won't affect anything. But if you want to rename things, or if you want to change the order of things, then it's a breaking change. So you have to think about that. So it's the usual versioning that you do today kind of applies there as well.
In case a server has to handle multiple requests at the same time, does the implementer have to worry about that, or does the gRPC framework care about that?
You mean multi-threading, basically?
Yes, multi-threading.
Yeah, it's thread safe, so it handles all of that.
So my question is basically, I didn't notice in the service contract, is inheritance of message types supported or generic methods for service definition?
Inheritance of message type. So you have one message that inherits
so
from.
you basically don't duplicate the code.
I'm not sure actually. It's part of protobuf, so if protobuf supports that, it should be supported, but I have to check, I don't know. Yeah.
Because whenever I see a service contract, I remember giant VSDOS. So.
All right, any more questions?
Yeah, I have one. Does it already work in the browser, and how does it relate to WebSockets?
So it doesn't work in the browser yet, but there's a working group that's working on that basically. If you're interested, I can send you the link for the working group. There's a technical reason why it doesn't work in the browser yet, but there's a group that's trying to support that. And what was the second question?
How does it relate to WebSockets?
So I guess it will use WebSockets, I'm guessing, so for the connection, but I'm not part of the working group, so I don't know the details. Yeah. More questions?
Hi, thank you for the talk.
Yep.
I was wondering, how could I migrate an existing RESTful JSON endpoint to this gRPC? Because it would run on a different port, right?
I mean, you have
With a
to.
different service.
Yes, but there's actually a way to support an endpoint that supports both JSON and gRPC using Google Cloud Endpoints. So in Google Cloud Endpoints, you can basically specify, you can basically have an endpoint that supports both JSON and gRPC. So you can do it that way. And there's a blog post on that I can send to you if you want.
Cool, thank you.
Yep.
The question is not particularly framework related, but you explained the speedy protocol and usage of HTTP2 that is non-blocking. I wanted to know if you understand the streams being passed, for you to construct a meaningful message, you need both the data and the header, right? So assuming like you have a chat client, you receive the data and header, but you will receive the entirety message only when you have like both the parts, right? Yep. So what exactly is the non-blocking thing then about HTTP2?
The thing is, so instead of having data and headers all at once, they are broken into two separate pieces, and they can be sent in any order, right? Of course, you need to get both so that you can construct your message and make sense of it. But the thing is, you're not like your data, for example, if it's ready, it's sent right away. It doesn't need to wait for headers, or the headers don't need to wait for data. And then things can happen in between. There can be other streams with other messages that can be sent as well. So you're not really like waiting for the whole thing to get together, and then you're also not waiting for someone else's request to finish before you can get yours. That's the non-blocking part, basically. Things are like smaller, and they can be sent at any time without having to wait for someone else. All right.
Okay, then. Thank you.
Okay, thanks very much. And those of you who filled, come and get your T-shirts, and I have stickers.